Hello everyone. In modern automation technology, robotic arms as an important component of robots. It play an indispensable role in manufacturing, assembly, and logistics industries. Robotic arm can perform precise manipulation tasks such as gripping, handling, stacking. The different cameras carried further expand the functional range of the robotic arm, give robots better perception capabilities, enable them to autonomously adapt and complete tasks in a changing environment. The vision system of the robotic arm is currently divided into two main methods, eye-to-hand and eye-in-hand. Eye-to-hand, the camera is located outside the robot body. The robot operation process needs to be remotely monitored and guided by a visual system. This method is suitable for fixed operation scenarios, such as cargo palletizing, material handling on production lines, and so on. The advantage is that the camera is not directly installed on the robotic arm. Therefore, users can adjust the position and angle of the camera as needed in order to achieve optimal field of view coverage. And the robotic arm does not need to carry additional weight, which helps to improve the speed of movement. The disadvantage is that the camera is located at a certain distance from the robotic arm, which may affect the positioning accuracy, not suitable for scenarios that require frequent adjustment of the working position. Eye-in-hand, mount the camera directly on the robotic arm to form a compact working unit. This method enables the robotic arm to obtain accurate image information of the target object and perform precise positioning and grasping based on it. The core of this technology is to use machine vision technology to convert visual information into commands that the robotic arm can understand, thereby achieving autonomous operation. The advantage is that the camera is integrated with robotic arm. The information transmission error is reduced, and the positioning accuracy is improved. It is suitable for complex and changeable working environments, such as precise operation in a small space, tracking dynamic objects, and so on. The vision system moves with the robotic arm and is always aimed at the target object. It can better adapt to the changing working environment. Based on the above advantages, Yaboom and Elephant Robotics jointly applied the concept of eye-in-hand to JetCobot 7DUF AI Visual Collaborative Robotic Arm. This design allows JetCobot to achieve precise positioning operations without external camera calibration. JetCobot with 7 flexible joints, unique bionic design concept, UR robot-like configuration, payload up to 3330G, bevel, all millimeter level repeatability. Able to perform precise operations in 3-dimensional space. For example, color recognition, face recognition, gesture recognition. Whether it is object gripping, handling, or tracking, it can be easily achieved. JetCobot is equipped with NVIDIA Jetson series board. By integrating row system and inverse kinematics algorithm, it simplifies the complex motion control of 7DUF robotic arm, can realize robotic arm coordinate control, motion planning, collision detection, gripping, and sorting. When robotic arm with an ordinary camera, it is mainly used for object recognition and positioning on a 2-dimensional plane, suitable for handling relatively simple tasks, for example, sorting or assembling objects in a single plane. Ordinary camera can only capture the plane position information of objects, such as X and Y coordinates, cannot directly provide the depth information of objects in the z-axis direction, so this configuration is not suitable for tasks that require precise 3-dimensional positioning. In contrast, when robotic arm with a depth camera, it cannot only obtain the position information of the object on the horizontal and vertical planes, but also accurately measure the distance between the object and the camera, that is, the depth information in the z-axis direction. This allows the robot to accurately determine the exact location of an object in 3-dimensional space. This is very important for applications that require highly precise positioning. The 3D data provided by the depth camera can help the robotic arm understand its operating environment, achieve more complex tasks, such as tracking, gripping, or assembling objects in a 3-dimensional environment, even avoiding obstacles in complex spaces. In addition, 3D visual data can also help the robotic arm achieve advanced functions, such as automatically adjusting the grasping angle, identifying objects of different shapes and sizes, and responding in real time in dynamic environments. These capabilities greatly expand the application scope of robotic arms, enabling them to play a greater role in manufacturing, logistics, medical care, services, and other fields. With the development of visual recognition technology, and RGBD cameras are becoming more popular, In recent years, eye-in-hand robotic arms have gradually become popular in commercial and industrial solutions, and even began to appear in some educational products, such as the latest DoffBot Pro developed by Yaboom, Depth Vision Robotic Arm, the eye-in-hand design, and REBD depth camera. Not only improve the visual perception of the robotic arm, will also increase the depth perception function so that the robotic arm can more accurately identify and locate objects in complex environments. With excellent flexibility and positioning accuracy, it can adapt to various application scenarios, such as 3D environment gripping and tracking, etc. The integrated depth camera enables DoffBot Pro to handle more complex tasks and more sophisticated coordination, achieving more intelligent operations.